Throwback Thursday, the 15th of April. We're going to have our Throwback Thursday song.
You have to call me Dragon.
Wait. I think it might have even started.
No.
Alright. You guys are going to be solving solve quadratic equations by completing the square, section 8.3. Yes. Guys, so completing the square. We learned two methods so far for solving quadratic equations. We learned factoring for a long time, then we learned square rooting, which is what we did last time for today, okay? Today we're going to be learning a method called completing the square. What completing the square is good for is sometimes we have an equation that's not factorable. Do you guys remember sometimes where we have a trinomial, we make our x, and it was prime? Yeah. Okay, this actually takes those trinomials and it fixes it. It makes it so that way you can factor it. Okay, it's pretty cool. Okay, we're going to go through this chart a little bit though. Okay, so you might notice there's polynomials on the left and there's factors on the right, and there's some blanks here for us to fill in. This first polynomial, let's factor it. X squared plus 6x plus 9. How do you factor a trinomial?
You just do.
Nope.
There's no try. There's only steps.
GCF.
Okay, look for a GCF. Is there one?
Yes. No.
No. 3 goes into 6 and 9, but does it go into 1? No. Okay, so what do we do after that? Make an X. Very good, CC. What goes to the top of this X?
9.
9. What goes to the bottom?
6.
6. It's positive 3 and positive 3. Can we use our shortcut here?
Yeah.
Oh, dang double because A is 1. There's a 1 in front of the X squared. So how do I do my shortcut?
You just do it.
Nope.
You do 3. X plus 3, X plus 3. X plus 3.
X plus 3, X plus 3. Can I also write that as... Very good. Which is what I have written in the factor table.
Oh, because the thing is twice.
Yes.
Good job, man.
There are two of them being multiplied together, okay? So go ahead and fill in the factor table that 3, because it ends up equaling x plus 3 being squared. Questions on that?
No.
Okay, we're going to do the same thing on the next one. So x squared plus 8x plus 16. What do we do? Yes.
They all are the same.
Oh, let's go ahead and
Make an X.
make an x. What goes to the top of this x?
8. 16.
16. What goes to the bottom?
8.
Two numbers that multiply to positive 16 add up to
4.
positive 8. 4 and 4. And what are our parentheses going to be this time? X plus 4 and x plus 4. Hey, are those parentheses the same?
Maybe.
So can we call it x plus 4 quantity squared?
Probably.
Yeah. Ooh. Now on the first two guys, shh.
Sorry.
Phoenix, put it away. We're noticing all addition signs. On number 3, what do we notice is different?
There's a negative.
There's a minus here, a minus 10x, and what do we notice inside the parenthesis?
Minus.
There's a minus. It's x minus something, okay? So let's go ahead and factor out this third one here. So let's make the x. What goes to the top of this x?
25.
25. Haha, the funniest number. What goes to the bottom? Negative 10. What are two factors of 25, haha, that add up to negative 10? Negative 5. Okay. Now, guys, calm down. Okay. Now, can we use our shortcut here?
Yeah.
Yeah, are we going to end up with the same parentheses again? Yeah, because it's the same numbers on the side. So can we just go over here to our factor table and just say x minus 5, thank you, being squared? Yeah, we can. Okay. Now, ooh, there you go. Do we notice here, if we go over to the factor table and compare it to the polynomial side, 3 times 3 is?
9.
What's double 3?
6.
6. 4 times 4?
16.
Double 4.
8.
5 times 5?
5.
Double negative 5?
10.
Negative 10. Is it reasonable to say that this would be 7 on the next one then? Because what's negative 7 squared?
49.
49. What's negative 7 but we double it?
Negative 14.
Negative 14. Is that reasonable to say that we see a pattern there?
I would say so.
Okay. Now here in the next one, based upon that pattern,
That logic.
What do we think these two blanks might be? No blurting. All right, Amy, what do you think the one inside the parenthesis is? 10. Okay, Amy, what do you think the one over on the left-hand side is then? 100. I would agree. Okay, now, Amy, how did you get 10 inside of the parenthesis? Okay, what would add up to 20? So you did half of negative 20, right? And you got negative 10. Now then, Amy, how did you get 100? Yeah, negative 10 times itself, or squared, is 100. Questions on that?
No, I think I got
Okay,
the next
no blurting. Go ahead and try this next one. Go and try writing it down on your own if you can even. Jill, what are you thinking? 64 and 8. Mally, can you explain why Jill got 8 in this parenthesis? Because 8 plus 8 is 16. It's half of 16, okay? Sarah, can you explain why Jill got 64 on this blank on the left? 8 times 8 is 64, right? Okay, now what's different on this second to last box? There's no number. It's just the variable, b. Now, is this the b term in the middle anyway? Like ax squared plus bx plus, right? It's a b term. We know that.
Yep.
Now, what have we been doing to the b term to get whatever's in the parenthesis? Dividing by 2. We've been taking the b term and dividing by 2, right? Does that make sense? Okay. So what do we think I might put in this parenthesis? Do we know what b divided by 2 is?
No.
No, but can I write
Yes.
b divided by 2? Yeah, so I'll just write b divided by 2. And then what have we been doing from there to get the other blank? What have you been doing with the number in the parenthesis to get the other blank? Multiplying it by itself, squaring it. We square it. So what am I going to do with b divided by 2? Square it. Do I know what b divided by 2 squared will be? No, but I can write it b divided by 2 being squared. Now I could end up saying that's b squared over what number? I could call that b squared over what number if I wanted? 4. I could do b squared over 2 squared, which is b squared over 4 if I wanted. Okay? Does that make, that one's a little more conceptual. Does that make sense though to us or no? Okay, a little more conceptual to us. A little more abstract maybe. Okay, using that same line of reasoning, if it's 7 here, what do we think we're going to put here in fraction form in that right-hand blank?
B divided by 7.
Okay, what's b though in this case? 7, so 7 divided by 2. Now, 7 doesn't divide evenly by 2 though, does it? Okay, so what am I going to do on the left-hand blank?
7 divided by 2 squared.
And square it. Now I'm actually going to write this one out here. What is 7 squared on the top? Nope. 49. And what is 2 squared on the bottom?
4.
So it ends up being 49 over 4. So with this pattern, we ended up figuring out a lot of these different blanks, right? We're going to talk about more of that after lunch. We went over this table. We filled in this table. We said, hey, there's a pattern here, okay? The pattern was that we took the square root, or excuse me, half of b, put it in the parenthesis. And then we squared that and got the last blank. What?
I'm like 5'2".
Okay. Now, what?
We square B and put it in parentheses.
Yeah, ooh. All right. So to solve equations, guys, let's bring it back down.
No, let's bring it back down.
No. Let's bring it back down.
Run it back
Yeah,
down.
during our break, let's take
You
a
can
nap.
handle it, I promise.
Thank you.
Sure, Will.
All right.
Take it.
So we're going to do this process called completing the square for this. Okay. It has 5 steps. The first step is to move the c term. Now, every quadratic has a c term. The c term is the one without any x's, right? Ax squared plus bx plus c. We want it to be alone on the right-hand side. We want it to be ax squared plus bx on the left equals just c on the right. Then we're going to put a blank line on each side. Then number 3, we're going to fill that blank line. We're going to add the square of half the coefficient of the middle terms. That's actually what we just got done doing up above, believe it or not. Then we're going to factor the left side as the square of a binomial, which is also what we did above, and solve the quadratic equation to simplify. We're going to walk through it with this first example. X squared plus 10x equals negative 4. On this one, is c alone on the right-hand side?
Yes.
Yeah, so step 1 done. Yeah, so I can go ahead and put a check next to it. I'll just do that. That way we see, yep, it's done. It's taken care of, okay? That way we can visually see it if you want to. Step 2, what's it saying?
Put a blank line on each side.
Yes, so what I'm going to do is I'm going to rewrite this. X squared plus 10x. And I'm going to put plus blank. Equals negative 4 plus blank. So you guys notice how earlier in our table up above, we had those blanks at the end of these trinomials. We had this plus blank. Okay? Is that kind of what we have right here?
Yeah.
Yeah. Now, that's step 2. Step 2's not too bad, is it? Put a blank. Can we do that? Yeah. That's not even math. Step 3. Add the square of half the coefficient of the middle term to both sides. Right on the blanks. Okay, well, what this is saying is half the coefficient of the middle term. What's the middle term here?
Blank, we don't know.
What's the middle term? The middle.
10x.
10. So what's the coefficient of the middle term? 10.
1.
What's...
X.
No.
2.
No, stop learning. That's not helping. Okay, the middle term is 10x. So the coefficient of the middle term is 10. Coefficient is the number with the variable.
That was my next guess.
Okay?
That was mine. Shh.
I was saying 1, 2, 3, and then I was going to go up to 10.
Okay, so it wouldn't have been your next guess then.
Yeah.
All right, so what's half of that coefficient? What's half of 10? 5.
I said 3.
Now it says square that. So what's 5 squared? 25. So we're going to add 25, the funniest number, to this blank. Now, if we've learned anything from algebra this year, it's that if we do something to one side of the equation, we have to do it to the other. That is step 3. Now, is that the same process we just did above?
Yes.
Okay, right in that table. Did we do that same process?
Yes.
Okay. Now, step 4. Factor the left side as a square of a binomial. Now, you might notice up here, we ended up getting to the point where we didn't even need to make the x to factor these, did we?
No.
Okay. We just said, oh, it's going to be half of b, and then it's going to be the same thing being squared. We can do the same thing here. If you want to make the x, you can, but there's going to be a much faster way.
I like this.
Because it's going to be 5. So it's going to be x plus 5 being squared. That ends up being factoring down to x plus 5 being squared. Questions on how this in the pink and blue in that step turned into the green.
Oh, there's the Africa song by Shakira.
Okay? What is negative 4 plus 25? Ha ha.
Negative
21. I'm going to write that down there.
Yeah, you did say it right.
Now, Danian, does this look like a problem we would have solved earlier today, like in our homework that we checked?
Heck
Or from
yeah.
last section? Yeah, I think so. Okay? Well, and so that was step 4, was factoring the left side. So now, what would you do to solve this quadratic equation? Phoenix? What was that? Okay, Logan? You what?
I say the square root.
Okay, is it?
Yeah.
Okay, then what?
Take the square root of both.
Take the square root of both sides. Okay, in this case, x plus 5 is all being squared, so we square both sides. Now, what are we left with on the left-hand side here? X plus 5. Do we know the square root of 21?
No, stop it, Brian.
No. Off the top of our head, so we call it plus or minus the square root of 21.
And that's our exact.
That would be the lead of our exact answer. But are we done with this problem?
Minus 5.
No, we have to subtract 5.
Then that's exact.
Now, can we call this 16 on the right-hand side? No, we can't. We can't add a number underneath the square root with a number not underneath the square root like that. So it ends up being plus or minus the square root of 21, minus 5. Now that's the exact answer, right? Could we go farther and do the approximate?
Yeah.
Yeah. Now this time, I'm just going to be asking for the exact answer. So are we done?
Yes.
Yes. All right. So the new steps 1 through 4 were new. Step 5 was solving the quadratic equation. Now those 4 steps, were any of those long steps? No. Honestly, none of those steps were very long. One step we moved it over, which was already done. The second step we added a blank. The third step we filled in the blank. Fourth step we turned into a factor. But we were able to use kind of a speedy shortcut for it because of this pattern we've been seeing. The cool thing about this method is every single time, literally 100% of the times, use this method called completing the square, and you go to factor it, you'll get something squared. You'll get something being squared every time, which makes this method handy. Now, the reason it's called completing the square is because, well, we're adding a blank, so we are completing this side. Does that make sense how we're completing this side?
Yep.
Okay? And it's called the square, completing the square, because what did we turn it into? Something being squared. Okay? Now, all of these up here, we did the same thing with it. We completed the trinomial, and we turned it into a square. So we completed the square. Does that make sense why we get that name? Cool beans. Let's go on to example 2. What would be the first step in example 2? Okay, it would be to add 3. Phoenix, is that what you're going to say? Cool beans. Phoenix did, you didn't see. So we're going to get x squared minus 4x equals 3. Now is C moved over to the right side by itself?
Yes, sir.
Good. Now wait, I know I'm going to be adding a blank, don't I?
You do.
So could I, in this step, leave space for a blank?
Yeah.
I totally could. Would that save me room and time? Sure, so if you remember to, it's a good idea. Okay? So at the end of step 1, if you remember to leave a blank on each side, leave space for a blank on each side, that's an awesome idea. So now we add in a blank. Yeah, Hayden. Yeah, are you able to finish this example with us or no? Cool. So we're going to add a blank to both sides. And so now we need to fill in this blank. Well, what are we going to fill in this blank with? Well, it ends up being positive 4. How does it end up being positive 4? Walk me through those steps, Bailey. Yep. Oh, okay. Walk me through those steps, Lincoln.
So you divide the 4 by 2.
You divide the negative 4 by 2 and you get
Negative 2.
negative 2. And then what do you do with that negative 2?
Square the negative 2, and that's what makes it positive.
And that's what makes it a positive 4. So that's the reason we add a positive 4
Thank you.
to both sides. Once again, you take half of the middle, half of the b, in this case negative 2 is half of it. You square that, which is a positive 4, because a negative times a negative will always be a positive. So you'll always add. Does that make sense why you'd always add? Because you're going to be squaring it. So even if you start with a negative, you'll get a positive. So now, does that left side factor at this point?
Yes.
Yeah, it should. Can anyone tell me what this left side might factor into? Give us a hint. It's going to start with x
7.
and something squared.
X plus 2 plus 3 squared equals 7.
Close. X minus 2. Can someone tell me why it'd be minus rather than plus? Because there's a negative with the 4x. Every time, guys, we're going to take half of b and it's going to be in the parentheses. Every time, half of b will be in the parentheses. Not a coincidence. Coincidence? I think not. Okay? So Bailey knew it was going to be 2 because that's half 4, but in this case it just needs to be a negative 2. That's being squared, and that's equal to, Bailey said, 7. Because 3 plus 4 is 7. That's step 4 done. Once again, do any of these steps take a ton of time?
No.
Honestly, no. We've had other problems that take way longer, don't we?
Like last unit.
Okay, like last unit. Okay? Now what do we do at this point? Square root both sides because it's isolated. Very good, Bailey.
X squared of 7 though.
You're right, we don't. So we just call it x minus 2 is equal to the positive or negative square root of 7.
Plus 2.
So we add 2 to both sides. Very good, you two. Now we don't know the square root of 7 plus 2, but we can write it.
We sure can.
Very good. Now, once again, if I'm just asking for the exact, are we done?
Yes.
Yeah, we can't go any farther without putting in a calculator. Now, if I'm asking for the approximate, are we done?
No.
No, but in this case, I'll just ask for the exact right now. Okay? Not on the homework today.
Thank you.
I might later on other assignments, just so you know. You're welcome, buddy. Yes. Good luck. Thank you for waiting, buddy. All right, question on any of that, guys? Okay, anyone still need this? Okay, give me a thumbs up if you're feeling pretty good about these. Thumbs down if you're not. I want to see everyone's feedback here, okay? Okay, I want to see everyone's... Nope, either you're feeling good or you're not.
What if you're not feeling good? What if you're feeling both?
No.
What if you get it most of the time, but then
Okay.
pressure, I'm sure.
If you're feeling 100% good, if you're feeling even slightly not good. Okay? Okay, cool beans, thank you. Let's continue on. First example. X squared plus 6x equals 18. Step 1 would be to do what?
Do the thing.
Get 6 by 6.
Get 18 by itself.
Get the 18 by itself, and it already is.
Already is though, Mr.
Step 2. Add the blank.
You gotta rewrite it. You gotta make
It might be the easiest step, but it's also probably the easiest step to forget.
Because it's easy.
99.
And it is going to be 9. How'd you arrive at 9, Phoenix?
Because half of 6 is 3.
Arrive at 9.
Times 3 is 9.
Very well said. Half of 6 is 3, and 3 times 3, or 3 squared, is 9. So we had 9 to both sides. What?
9's out of the alphabet. It got 8 by 7.
9 was never in the alphabet because it's not a letter. All right. What does the left side factor into?
3.
We use a 3.
Oh. So I want to.
X plus 3 squared.
What?
3 squared.
X plus 3 being squared. We're always going to do the x, the variable there. And then we're always going to have the square root of that one. Whatever we squared a moment ago is going to go in the parenthesis. Whatever we squared a moment ago is going to go in the parenthesis. And what's it going to be equal to? 27.
18 plus 9 is 9.
Because that's 18 plus 9. Now from here, would we solve this like we normally do?
Probably.
Yeah. Go ahead and try this one on your own. The rest of this on your own. Just the exact here. We square root both sides. Means the square term's already by itself. X plus 3 is equal to positive negative square root of 27 because we don't know the square root of 27. From here we subtract the 3. X equal to positive negative square root of 27 minus the 3. There we go. Questions on that at all?
Nope. Not at all.
Yep, good luck. Okay, let's go and try number 2 on your own. Is C already by itself?
Yes.
Yeah, we call that a win, okay? So we add the blank in. A squared minus 2a plus blank is equal to 4 plus blank. Now, what's going to go on our blank here? 1, because half of negative 2 is negative 1. We square that, we get positive 1. So when we go to make our factor, though, we're going to do a minus 1. Why is it minus, Ash? Because the 2a is negative, okay? Now I said earlier, I noticed some confusion on what I said earlier, so I want to clarify that, okay? When I said earlier that we're always going to add a positive there, that's for the blank, because we always square that. But the number in the parentheses, that's not squared yet, okay? We squared that number to put it up on the blank. This number in the parentheses can be negative, and it will be negative whenever the b is negative, when that middle term is negative, okay? And then that's going to equal 5. So we square root both sides, and we don't know the square root of 5, so we call it a minus 1 is equal to positive negative square root of 5. From there, we're like, I add 1. A is equal to positive negative square root of 5 plus 1.
I had that.
I smell cap.
I don't. I had that right.
If I made a mistake, I am sorry.
I think I should take the class.
Questions on that?
And your next one, that's
Okay.
hard because I've already done it.
Oh, okay. Let's try this next one.
Okay.
We're going to do this next one together, actually, though.
Thank goodness.
Okay?
I know something.
Amy, what's my first step?
I'm not gonna spoil it.
minus 12.
Subtract 12, get the c by itself. Hayden, Logan, stop, please.
Yeah.
X squared plus 8x plus blank is equal to negative 12. Oh, I ran out of room. X squared plus 8x plus blank is equal to negative 12 plus blank. 16 and 16, very good. Half of 8 is 4. Square that, you get 16. So when we go to factor here in a second, x plus 4 being squared. We don't do half of the last one, we do half of the middle, okay? Whatever it was that we squared is there, okay? Now what's negative 12 plus 16?
4.
4. Now wait, what do we notice about 4 compared to our other numbers we've gotten at this point?
Perfect square.
27, 5. 4 is a perfect square. So are we going to have to even have a radical as our in part of our answer now?
No.
No, we're not going to have to deal with even having approximate answers be a possibility. Because as we go to square root, we can say definitively what the square root of 4 is. So we can say x plus 4 is equal to what?
2.
Close.
Positive negative.
Positive and negative 2. So now, what do we do?
Minus 1, 4.
You subtract 4. X is positive negative 2 minus 4. You have to factor in both options. Now at this point, do we split it?
No.
Yeah.
Oh, yeah.
Into a positive version and a negative version. X is 2 minus 4. X is negative 2 minus 4.
Negative 6 and negative.
The left version does turn into negative what? 2. The right version turns into negative 6. And those are the two answers. Now, could you check this by plugging it back in and seeing if it works to our original equation?
Yes, sir.
Sure. You can plug in negative 2 to both x's. It works. You plug in negative 6 to both x's, and it'll work. Question on that at all? All right, let's go on to the next page. I'm going to have us start examples 4 and 5, but not finish examples 4 and 5. Are you guys okay with that? So that way you guys get on to the homework sooner.
I don't like homework.
All right. Example 4 here. Wait, what's different on example 4 compared to earlier, guys?
The 4x is there instead of minus 9.
C's on the
Subtract
left.
4x. and
C's on the left, B's on the right. So, Mally, what do we do to fix this?
You subtract the 4x.
Subtract the 4x to move it over. So we have x squared minus 4x minus 9 equals 0. So then, Lincoln, what do we do?
Add 9.
Add 9 to move it back over. We got to move the C over. So sometimes it requires a little more rearranging like it did here. That was the only difference between this and a problem we've had earlier, wouldn't you say?
Yeah.
I would say.
Okay. Bless you, must rain down after this great. Now, would we be done here? No, we need to add in the blank and keep on going. Okay? But we're going to stop there on this problem for today because of time's sake. Yes, Mally?
How do you can't with
Say it again?
the problem if you take the 4x in half, it'd be -2.
You're right.
But
So
then if you put that in and you try and square it, it would just
you get positive 4.
Yeah, but like with the 9.
Yep. So you add the 4 either way.
Jump, Allie.
Does that make more sense, Mally?
Yeah,
All right.
that wasn't me being silly. I was actually.
You're good. You're good. All right, let's move on to number 5. What's different about number 5? Lincoln, put it away. What's different about number 5?
It's a quadnomial.
Okay, we see 4 different things. What do we see 2 of? Are there 2 C's?
Yes.
Yeah, there's a C on the left and the right. Does that change what our first step is, though?
No, we
You
can
gotta
combine
add them
them.
and then you do.
No. So what are we going to do for our first step?
Combine them.
I know.
Mally.
You put the plus 8 over there, but you combine them.
Yeah, we add 8 to both sides. And this time as we add 8, instead of adding 8 to 0, we're adding 8 to negative 4, which gives us 4. Now from here, would we still put our blank in and continue on like we had been? You betcha. Okay? Now once again, we're not doing that because of time's sake. Okay?
What if we need to for reassurance?
Okay.
Then you
Well,
turn around.
yeah.
I will.
Okay. And we're going to skip number 6 in its entirety. Okay? Now I'm going to hand you the homework, and on our homework, you just need to do the exact answers today, okay?